Okay, welcome guys. We have a short video dealing with parallel lines crossed by what we call transversals. So the entire lesson today is on that concept. So we're going to look at two different cases, one where parallel lines are the same plane, and one where we have parallel lines on one plane. Talk about some important concepts between them. So if you have two lines that do not intersect, they're going to be parallel or skew. So remember, skew lines are coplanar, or excuse me, parallel lines are coplanar. So parallel lines are always going to be on the same plane. However, skew lines, so if I were looking at this picture over here, I got two different planes. Maybe I draw another line on the bottom plane U. It turns out that the line on U and any of these two will never cross. Those are what we consider to be skew. So let's jot that down. Skew lines are not coplanar. So two lines in the same plane are either going to be parallel or they're going to intersect in one spot. If two lines intersect at a 90-degree angle, then we say the two lines are perpendicular, denoted by an upside down T. And if two planes that don't intersect, like in this picture, we would say they're parallel planes. So let's look at a picture of, maybe a rectangular prism. And let's see if we can identify some basic components. So if I were looking at this picture, and I want to know lines that are parallel to ED. So that's this line in the corner and contains point C. Well, the only line that's going to be parallel that contains C is CF. So that would be line CF. Now let's identify lines that are skewed to ED. Let's be very specific and contains point A. Well, if you look carefully, you'll notice that AG is the only line that doesn't is going to be on containing point A that's on a different plane. AH would be parallel to DE. AB would be not touching DE, but it would definitely be perpendicular in nature. So the key is the lines cannot be either parallel or perpendicular in nature. They have to be kind of going different directions. So I could argue AG would be the best line. That is skewed ED, containing point A. Now another example of lines that are perpendicular to ED, let's assume it also contains point A. Contains point A. Well, that would be line DA. And then lines that, or excuse me, planes that are parallel to ABH. Well, ABH is this little side. So then this one right here, FED, is definitely parallel. All right. So it turns out that if you have a point that is not on the line, there's exactly one line through P that you can draw that is parallel to point or to the other line. That's called the parallel postulate. Turns out that there's also one line through P that is perpendicular to line L. That's called the perpendicular postulate. That's the shortest distance from that line to point P. So let's look at a picture of a scenario where we're going to answer some questions from a diagram. Name a pair of parallel lines. Well, AB is parallel to CD. You can also see that this angle is 90 degrees down here because this one's 90 up here. And because these are parallel, so if that one's 90, this one has to be 90. So be, look, so you could also, look for that relationship. We talk about perpendicular lines because AB is definitely perpendicular to AC. You could argue that AC is perpendicular to CD, but they just want A pair. So you can tell from this picture that AB is not perpendicular to BC because the angle they cross is not 90. So we're going to say no, the intersected angle is not 90. Okay. So another important skill guys, is when you're looking at lines that cross, is you have vertical angles. So like 1 = 3, 4 = 2. We talked quite a bit about those already. So that's something you want in the geometry you always want to see when lines cross. Another important concept is when lines cross, where you have specifically one line that crosses two other ones at two different spots, we call that a transversal. So a line that crosses two or more different lines at different points. So what you'll notice is that you'll start seeing angle pair relationships. So like in the first picture, you notice 2 and 6 are in the same upper right hand location. We call those corresponding angles. I could name all these other ones too and match up their corresponding parts. Another popular one is called alternate interior angles. So what that means is they alternate across the transversal, and both of these angles are inside the line. The transversal goes right through it. So the relationship for the name of those is the alternate interior angles. Another popular one is where you would have alternate exterior angles. They're on opposite sides of the transversal, and they're both exterior to those lines. Another popular one is called consecutive interior angles. So what that means is that when a transversal crosses two lines, you form two inside angles that are on the same side in their interior. So let's see if we can kind of recall these from a basic picture. So let's say that I had one transversal in our picture that crosses two lines. A pair of corresponding angles would be 1 matches 3, 2 matches 4, 5 matches 7, 6 matches 8. Let's jot those down. Angle 1 and 3, 2 and 4, 5 and 7, 6 and 8. A pair of alternate interior angles would be the interior angles are 2, 3, 6, and 7, by the way, right? So the alternating ones would be 2 and 7 and 6 and 3. 2, 7, 6, 3. A pair of alternate exterior angles would be 1 and 8. Those are outside angles. They alternate. And so does 5 and 4. A pair of consecutive interior angles would be like 2 and 3 and 6 and 7. And then a pair of vertical angles would be 1 and 6, 2 and 5, 4 and 7, 3 and 8. So on your assignment today, they may add one more transversal, and they may add extra angles. They might put 9, 10, 11, 12, 13, 14, 15, 16. So if I ask you questions about these angles, you're going to look for those same relationships. So like 10 and 2 are corresponding because this line would be the transversal. Okay. 10 and 6 would be consecutive interiors because the same line is the transversal. But 10 and 7 wouldn't have any relationship. So like 10 and 13 would because this line would be its transversal. That would be consecutive interior angles. 10 and 15 would be inside alternate or alternate interior angles with this transversal. So it all depends on what the transversal is or where it's located. Okay. So like 2 and 7 is alternate interiors across this transversal. 2 and 10 is corresponding across this transversal. So we'll get better at these, but for now I want you guys to just identify them. Okay? So I want you to answer these questions on your assignment, and let's get them done in class today.